So amphoteric oxides also react with bases or alkalis to form a salt and water. Then acidic oxides react with water to form acidic solutions, and they react with alkalis or bases to form a salt and water. Please, these are very important things to note because you are going to use it throughout your chemistry in all levels, O level, A level, university, and even outside university. You are still going to use these properties. Good, please master them. Then the same things have been given here. We are saying that basic oxide will react with water to form an alkaline solution. An alkaline solution has hydroxyl ions in it. We shall look at that, don't worry about that. Then a basic oxide will also react with an acid to form a salt and water. But now the cation, which is actually the metal ion in the salt that is formed, is going to come from the base. Okay? We shall look at that, don't worry. Then amphoteric oxides react with acids to form a salt. Again, the salt is getting the cation, which is the metal ion, from the base, plus water. Amphoteric oxides still can react with the base to form a salt and water. Okay? Then acidic oxides can react with the base to form a salt and water. Acidic oxides still can dissolve or can react with water to form an acid. An acid is represented with hydrogen ions. Okay? Good. We are emphasizing these properties because they are extremely important. Okay? So you are going to simply encounter reactions in chemistry which just require you to have this concept at your fingertip. Please, please, and please, I emphasize, master these properties. These are summaries of chemistry. Good. Now, the other categorization which we looked at were peroxides. Peroxides, we said, are oxides which have twice as more hydrogen, rather, as more oxygen atoms as the normal oxides. Meaning that if a normal oxide has one oxygen atom, then a peroxide of that normal oxide will have two oxygen atoms. For example, the oxide, the normal oxide of hydrogen is water, and it has only one hydrogen, rather oxygen atom. Let's look at that. So water has this formula, H2O. It has this one oxygen atom, but hydrogen peroxide, the peroxide of hydrogen, has two oxygen atoms, as you can see there. That is a peroxide. Its normal oxide has one oxygen atom, but the peroxide has two. Let's look at another example. Sodium peroxide. Sodium peroxide, the normal oxide of sodium is sodium oxide, which has this formula, Na2 capital O. This has one oxygen atom, but look at the formula of sodium peroxide. It has two oxygen atoms. That shows that it is a peroxide. So peroxides will always have twice as much oxygen as their normal oxides. Then we have mixed oxides. Mixed oxides behave, chemically react like a mixture of two normal oxides. Okay? A mixture of two normal oxides. So it behaves like one normal oxide and also like another oxide. It's like both normal oxides are in the same compound. For example, we have here triiron tetraoxide. Tri means 3, so 3 iron atoms, and tetraoxide. Tetra means 4, so 4 oxygen atoms. Okay? So, if you looked at this, it is a combination of two normal oxides, which are iron 2 oxide, which has this formula, capital F, lowercase a, e, and capital O, plus iron 3 oxide, which has this formula, capital F, lowercase e, 2, subscript 2, capital O, and subscript 3. When you combine these two, you realize that iron becomes how many? Atoms of iron now become 3. So iron atoms are now 3. Okay? Then oxygen atoms, 1 plus 3, you will now have 4. So oxygen atoms are now 4. That is what we have in this formula. In that formula there. So this triiron tetraoxide behaves like a mixture of iron 2 oxide and iron 3 oxide. Very interesting chemistry. So, and now after learning oxides, you should be able to appreciate that oxygen does not exist only in the atmosphere, but it also exists in a combined state. We have realized that many metals and non-metals can be combined with oxygen to form oxides. When the oxides are metal oxides, they can either be basic oxides or amphoteric oxides. But when they are non-metal oxides, they can either be acidic oxides or neutral oxides. Acidic oxides are also called acid anhydrides, and they dissolve in water to form acids, and they react with bases to form a salt and water. Basic oxides dissolve in water to form bases or basic solutions or alkaline solutions, and they react with acids to form a salt and water. Okay? Neutral oxides are neither acidic nor basic. They don't react with acids, they don't react with bases. Okay? Then amphoteric oxides are both acidic and basic. They react with acids, they also react with bases. Okay? Now, points to note very importantly is that any acidic oxide, when you react it with a base, you form salt and water. Any basic oxide, when you react it with an acid, you form a salt and water. Bases do not react with bases. Acids do not react with acids. Thank you for following this lesson, and please make a summary of this lesson and give proof that you have made your summary of this lesson. Thank you. God bless you and have a blessed time.